This is my Lab 1 report for Physics 2. So the main purpose of this lab was to determine the interactions between two charged pieces of tape, and the models and principles used were Newton's third law and Coulomb's law. And the main results from this lab were that both the pieces of tape had a negative charge, and the magnitude of the charge on the tape was 6.26 times 10 to the negative 9 coulombs. And there were 3.91 times 10 to the 10 excess electrons on the tape. The main data that was determined during this experiment was that the length of the tape was 0.24 meters, the width of the tape was 0.019 meters, the mass of the tape was 0.00025 kilograms, and the separation distance between the tapes was 0.012 meters. The gravitational force was 0.002453 newtons. The electrical force was the same as the gravitational force. The amount of charge on a piece of tape was 6.26 times 10 to the negative 9 coulombs. The amount of excess electrons was 3.91 times 10 to the 10. The number of atoms on a piece of tape was 4.56 times 10 to the 17. And the ratio of excess electrons to the number of atoms was 8.57 times 10 to the negative 8. The main physics idea that was explored in this lab was Coulomb's law and how like-charged particles interact with each other. And for this experiment, it was achieved by having two negatively charged pieces of tape interact with each other and noting their separation distances. And the system and surroundings for this experiment were the two charged pieces of tape and also a neutral object to determine if the pieces of tape were charged or not. Some assumptions that were made were that the pieces of tape were equally charged, the pieces of tape had an even amount of charge over their surface, there was no air resistance involved as well, and the calculations were assumed that all the charge was located at the center of each piece of tape. For the coding portion of this lab, I modeled that all of the excess charge was at the center of each piece of tape. And in my model, the orange arrow represents the electric force vector on the top piece of tape. The green arrow represents the gravitational force vector on the top piece of tape. And I made the same assumptions for my code that I did for my calculations, so the gravitational and electrical force are both the same. One of the additional questions for this experiment was, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? So the experiment would perform the exact same way, because if the charges were flipped, you would have both of the pieces of tape would have the same charge, and like charges repel, so it would end up with the same results. And another question was, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So when they are handled as little as possible, the excess charge on the tapes remain closer to what they were when they were first charged. And when they come into contact with other objects, other neutral objects, the excess charge on the tapes are lessened. This is because the other objects gain part of this excess electrons from the tapes to make sure the system has the same charge. By the end of the experiment, it was determined that each piece of tape was negatively charged, and since they were both negatively charged, the tapes ended up repelling each other. And to calculate the electric force on one of the charged pieces of tape, another charged piece of tape was brought close enough so that the charged tape hovered, and the separation distance was then noted. And since the charged piece of tape was hovering and didn't move, the net force on that piece of tape was 0. This means that the gravitational force and the electric force on the charged piece of tape was 0.